Hello dear students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So we are done with the PU2 syllabus, we are done with the PYQs of last 10 years of all the 10 chapters of PU2, right? So now from here we'll be moving towards the PU1 syllabus, okay? So I'll be covering all the chapters in detail. So as I told you, the weightage of PU1 chapters are very less, but there are certain chapters in which you need to give more time, and in PU1 also there are certain topics from certain chapters from where the questions are repeatedly asked. So if you can identify those topics and you can do questions from those topics, that is more than enough. Okay, so yes, now let's get started with today's class. So some basic concepts of chemistry I'll be covering in 3 parts. Okay, so in the first part we have the topics, that is nature of matter, that is today's video will be discussing these things. Okay, one second. So let us see here. So in some basic concepts of chemistry, I have divided the chapter into 3 parts, okay? And in the first part, that is in today's class, we are going to discuss nature of matter, properties of matter and measurement, and uncertainty in the measurement. So out of these all things, this topic is important from where you can expect the questions, okay? Next, part 2. Here we are going to discuss in the next class, that is laws of chemical combination, Dalton's atomic theory, and atomic and molecular mass. And in the part 3, which is most important, we are going to discuss mole concept, percentage composition, and the stoichiometry. Okay, now if you do not have time, then I will request you to watch only the part 3 when I'll make it. You can watch only the part 3 and then also you can consider that this chapter is done for you. But those students who are preparation is going on well and you have enough time, then I'll request them to watch all the 3 parts. Okay, so today I'll be doing part 1, in the next class part 2, and in the last class I'll be doing part 3 of this chapter. Okay, fine. So weightage wise, as you can see, 2024 one question was asked, so almost you can say 0 to 1 question can be expected from this chapter, because in 2022 and 2023 there was no question asked from this particular chapter. Okay, so that is why not a very important chapter, but yes, the mole concept is the thing which is required in all the chapters. In most of the physical chemistry you need that concept, so that is why this chapter is important. Okay, fine. Now today in part 1 we are going to discuss nature of matter, properties of matter and measurement, and uncertainty in the measurement. Okay, now if you see in the nature of matter, what are we going to study? States of matter and classification of matter. And then in the properties of matter and its measurements, we are going to see physical and chemical properties, international system of units, mass and weight and temperature. Then in the uncertainty in measurements, we are going to see scientific notation, significant figures and dimensional analysis. Okay, so these are the topics that we are going to cover in today's class. So let us start with the first topic, that is nature of matter. So on the nature of matter, first thing that we are going to study is the states of matter. So all of you might be knowing in your lower classes that matter can be in 3 possible states generally, that is solid, liquid and gas. Okay, so you must be knowing about the properties of solids, liquid and gas, that is like they have a definite shape, the intermolecular force of attraction is very strong, they have high density, right? So these all are the general properties of solids, liquids and gas, which I am not discussing because I hope this is there in class 6th, 7th also, so basic understanding everybody should be having. Next, coming to the second topic, that is classification of matter. Here let us discuss that how are matter classified. Okay, so yes, matter are classified first into 2 things, that is one is mixture and another is pure substances. Okay, mixture and pure substances. Now mixture can be of 2 types, homogeneous and heterogeneous. Homogeneous mixtures are those where the distribution is uniform. Okay, so homogeneous mixtures means uniform distribution. Okay, and heterogeneous mixture means non-uniform distribution. Okay. Now for example, if you prepare a sugar solution, right, the sugar particles are completely uniformly distributed throughout the solution, right? So that is why that is an example of homogeneous mixture. Now if you take a mixture of sand and water, then you will find that some particles of sand are deposited, some small particles of sand are floating, or they are in the middle of the, so that is not a uniform distribution. So that is why we can say that it is a heterogeneous mixture. Next, coming to pure substances. So under pure substances we have elements and compounds. So in elements what happened, we have only one type of atoms. Okay, sodium element. So we will have only sodium elements. If you have oxygen element, then you will have only oxygen atoms. If you have nitrogen, then nitrogen will have only nitrogen atoms. Whereas what is compound? Compound is combination of more than one atom in a fixed ratio, right? So for example, you have water, you have NH3, you have SO2, you have SO3. So you can see here different atoms have combined in a fixed ratio to give a molecule, and a combination of molecule is called as compounds. Okay, fine. So next, coming to the next thing, that is properties of matters and elements. So here also, first of all, there are properties are of two types. Certain properties are called as physical properties and certain other properties are called as chemical properties. Now which properties are called physical properties? That means those properties which you can measure, okay, without changing the composition of the matter. Without changing the composition of the matter, if you can measure any property, that is called as physical property. For example, mass, density, boiling point, melting point, okay, volume, these are temperature, these all are your physical properties. To measure that, we do not need to change the composition of the matter. Okay, now the chemical composition changes when measuring the chemical properties. So certain chemical properties, if you measure and their structure is changing, okay, then we call them as chemical properties. Now for example, here we have oxidation state, coordination numbers, okay, you can have then acidity, okay, basicity. These are what? These are your chemical properties. Okay. Next, coming to the International System of Standard Units or SI units. So here what we have, here we have different, there are total like 1, 2, 3, 4, 5, 6 and 7. 7 fundamental quantities, their symbol and their SI units. Okay, this is what you must remember, very very important. So for length, we use the symbol small l, and the name of the SI unit is meter and it is represented as m, small m. Okay, then mass, the symbol is small m, name of the SI unit is kilogram and it is represented as kg. Then time, it is small t, okay, and then we have seconds and it is represented as s. Similarly, electric current is I, capital I, then we have ampere and it is capital A. Next you have thermodynamic temperature, capital T, it is Kelvin and it is represented as capital K. Next, amount of substance is small n and it is moles and it is represented as mol, mole. Next you have luminous intensity, symbol is IV, it is called as candela and it is represented as CD. Okay, fine. Next, coming to something about mass and weight. So generally we get confused about mass and weight. So here you should remember that mass is the amount of matter present in any substance, whereas force, weight is the force exerted by the gravity on an object. Okay, so weight formula is equal to mass into gravity. Okay, so mass is a constant term whereas weight will be variable. So suppose your weight in the earth is 56 kg, it won't be same on the moon, because here your mass is multiplied with gravity to get your weight, right? So when you go to moon, the gravity will be different, so weight will also be different. Okay, next, coming to temperature. So the general the SI unit of temperature is Kelvin, right? But there are two other units also. There are two other units like Celsius and Fahrenheit. So the relation between Fahrenheit and Celsius is like this: degree Fahrenheit is equal to 9/5 of degree Celsius plus 32. Okay, this you should remember. And then you have Kelvin to Celsius relation, Kelvin is equal to degree centigrade plus 273.15. Okay, fine. Next we will go to something called as scientific notation. Okay, now first of all we'll see what are the things that we are going to study in this. First we will understand what is scientific notation, then we will be studying multiplication and division, what is the rule followed for scientific division, scientific notation, and for addition and subtraction, what is the rule followed. Now see here, what is the need for scientific notation? So when you deal in chemistry, okay, we deal with very minute particles, right, where the size is very less or the number of particles are too high. Okay, so it is not possible to write like if you see so many zeros are to be written. Okay, so it takes a lot of time and it is very tedious as well, right? So to solve this problem we have come up with scientific notation where you can represent the big numbers in a very easy way. Okay, so I'll be telling you how to write the scientific notation. Okay, so here are two examples. We need to write it scientific notation. So for scientific notation writing, what is the first rule? See, you should remember like this. Rule number 1 is there should be one digit before decimal. Okay, one digit should be there before the decimal. Next, rule number 2. Okay, if you are moving towards left, okay, if you are moving towards left, then value will increase. Okay, just remember I'll be explaining this rule. If you are moving towards left, your left, then value means numbers to, this is left side of the number, this is right side of the number. Okay, so if you are moving towards left, then the value will increase. And rule number 3 is if you move towards right, okay, then value will decrease. Okay, which value I am telling? Here value stands for power of 10. Okay, power of 10 will increase and power of 10 will decrease. Okay, so now let us see here. If this number, if you see 232508, can I write it as 10 to the power of 0? Any doubt here? 10 to the power of 0 can we write, because 10 to the power of 0 is 1, right? So that means this is the same thing. Now I want, the rule is that there should be only one digit before decimal. That means what? In this number, this decimal should come here, 2.32508. Okay, now into 10 to the power of, now see, you have moved towards left, right? We are moving towards left, then the value should increase. What is the initial value now? 0, right? So 0, here it will come 1 and here it will come 2. So I can write 10 to the power of 2. Okay, clear? I hope all of you are getting it. Next, let us solve this one. So if you see this one, there should be only one digit before decimal. You cannot put 0 before decimal. Okay, you need to have a number between 1 to 9. So that means I need to put decimal here, 1.6. Okay, and currently I can write it like 10 to the power of 0, and I need to make the decimal here, and I am moving towards which side? I am moving towards right. Okay, so I have to move this side to get a 0 here, right? So if I am moving towards the right side, the power of 10 will decrease. Now what is the power 0? So it will become -1, -2, -3 and -4. So I can write 1.6 into 10 to the power of -4. Okay, now let me take one more example. Suppose you have like 4 5s to 37.629, just a number. Okay, so here what you need to put? You need to put decimal before 4, right? Like after 4, there should be only one digit before the decimal. So I need to put the decimal here, 4.5237629. Okay, into 10 to the power of, now it is 10 to the power of 0 and we need 1, 2, 3 and 4. I am moving towards the left, so value will increase, so it will be 10 to the power of 4. Okay, getting? One more question, let me solve here. Okay, so suppose I have 25273 into 10 to the power of 2. Okay, suppose already the power is there. Okay, something like that. This is the decimal here. Yeah, here is the decimal. Okay, so okay, now if I want to write it in the scientific notation, the decimal has to come here, right? So I'll move two sides, so I'll get 2.5273. Now I am moving towards the left, value will increase, but this time it will increase from 2. It is already 10 to the power of 2. So I will increase one time, it will become 3, it will become 4. So into 10 to the power of 4. Okay. Next one, if I say, suppose I have like 0.000792 into 10 to the power of minus 5 is there. Okay, here this is an important example. Let me solve it on the top. 1 second. Yeah. So, so now suppose I have 0.000792 into 10 to the power of minus 4. Suppose this is there. Okay, and you need to write it in the scientific notation. So what was the rule? If you move towards left, value will increase. If you move towards right, then value will decrease, right? Left side if you are moving, then value will increase. Right side if you are moving, value will decrease. Value, I am telling value will decrease or increase. Okay, so now you see, in this case I am moving towards what? I am moving towards the right, so value will decrease. So what should be the value decrease? From minus 4, if you decrease the value, it will become minus 5, right? Then minus 6. So value will decrease in that order. So I can say that I need to put decimal here, right? So it will become 7.92 into 10 to the power of, here see, minus 4 was already there, now minus 5, minus 6, minus 7 and minus 8. Getting? Okay, so that is how you can find the scientific notation. So these big numbers can be easily represented using the scientific notation. Now how to follow scientific notation while multiplication and division? Let us check that here. Now see, suppose you want to multiply two numbers. Okay, so multiplication and division is very easy, nothing difficult. So in that case what happens? You need to, if it is multiplication, you need to add the powers. Add the powers of 10. Okay, so suppose I am solving this 5.6 into 6.9. So I will get this value as 3. Yeah, this value I will get. This to multiplication value will come 38.64. Okay, next what is there? You have 10 to the power of 5 and 10 to the power of 8. So I will add 5 plus 8 and that will be 38.64 into 10 to the power of 30. Okay, but is it a scientific notation here? No, right? Because you can see there are 2 digits before the decimal number, but I need only 1 digit before the decimal number. So I need to shift this side, right? Now which side I am shifting here? I am shifting towards left, right? Towards left I am going. If I am going towards left, then the value will increase. So 13 will become 14, right? So I can write here 3.864 into 10 to the power of 14. Okay, clear? Understood this one? Okay. Now let us see if it is division. In case of division, what you need to do? You need to subtract the powers. Subtract the power of 10. Okay, clear? So now this is only 5.5. okay, there is no point, it is only 5.5. so 2.7 by 5.5, so this value alone will give me 4909. okay, if I just divide. Next what I need to do? I need to subtract the power. So 10 to the power of, this is minus 3. okay, one power is this one, minus what is the another power? 4. okay, so how much I'll get? 0.4909 into 10 to the power of minus 7. Okay, now what you need to do? Now you need to write it in the scientific notation. So if you see, we need to have only 1 digit before the decimal. So I need to put this decimal here. So I am moving towards which side here? I am moving towards the right. right, of the number. Towards the right means the value will decrease. So minus 7 will become minus 8. Value has to decrease. So we will get here 4.909 into 10 to the power of minus 8. Clear? Here this side if you are moving, the value will decrease, so we will get minus 8. Okay, now let us go to next thing, that is scientific notation in terms of addition and subtraction. Here you need to take care of one thing, that is while adding or subtracting. Okay, the power of 10 should be made same. Okay, the power of 10 should be made same. Like that means here it is, you can see 10 to the power of 4, here it is 10 to the power of 3. So you can either way, you can either make this one 10 to the power of 3 or you can make that one 10 to the power of 4. Both are fine. Okay, so I can see, let me try like making this one as 10 to the power of 4. Okay, so if I move this to left side, right, if I move this decimal to the left hand side, right, then I am moving towards left hand side, that means what, value will increase. So this will become 10 to the power of 4. So I can write like this, 6.65 into 10 to the power of 4, okay, plus 0.895 into 10 to the power of 4. Okay, now what is there? Now we will add here 6.65, okay, 0. We have 8, 9 and 5. Okay, so if I add, I will get 7.545. Okay, so 7.545 into 10 to the power of 4. Okay, now I told you there is another method, like also you can change this one to 10 to the power of 3. So if you want to decrease the value, you need to move towards right. So if I make this as, like for example, I can write it as 66.5 into 10 to the power of 3, and this side we have what, 8.95 into 10 to the power of 3, right. So now if I add these two, so what I will get, 5, 9 plus 5, 14, 8 plus 1, 9 plus 6, 15, 6 plus 1, 7, right. 75.45 into 10 to the power of 3 I got, right. But again, this is not the scientific notation because we need to have only one digit before the decimal. So I will move this side. Moving this side means moving towards your left. If you are moving towards the left, the value will increase, right. So moving towards the left, value will increase. So I will get the same thing, 7.45 into 10 to the power of 4. Okay. Now coming to subtraction, the same rule applies here. In subtraction also the power should be made same. Okay. Now see, what I can do is I will make this one as minus 2. Okay. So minus 2, if you are changing from minus 3 to minus 2, what you are doing, you are increasing the value, and to increase the value you need to move towards left. So I will make the decimal point here. So I can write 2.5 into 10 to the power of minus 2 minus 0.48 into 10 to the power of minus 2. Clear this one we got? Okay. Now if I subtract this one, right, 2.5 minus we have 0.48. Okay. So we will get 2.02 into 10 to the power of minus 2. Clear? 2.02 into 10 to the power of minus 2. Clear? That is what you should remember. When doing addition and subtraction, the power of the 10 should be made first same, and then you should either add or subtract. But in multiplication and division there is no such rule. You can just multiply the two numbers and add the power of 10s, and you can divide two numbers and you can subtract the power of 10. Okay. Now coming to next thing, that is significant figures. This is very important. So we will be discussing these topics regarding significant figures, like what is the need for significant figures, why it is important. Second, we will be discussing about how to find the number of significant figures, what are the rules to be followed. Then we will discuss something in brief about precision and accuracy, Then we'll be also discussing how to calculate significant numbers while adding two numbers and while dividing and multiplication of two numbers. And lastly, we'll discuss about the rules to round off. Okay. So first of all, we will talk about the importance. So you can see here, what is the meaning of significant numbers? Okay, significant numbers are meaningful digits which are known which are known with certainty plus 1, which is estimated or uncertain. Now suppose when you do certain measurements, okay, suppose there is a stick and you are measuring it. So it is not like you will not get the accurate results. Okay, you cannot get the accurate results in every case. So there should be like, so you may be telling like, okay, it may be something around 4 point something centimeter. So that 4 which you are very sure, that is the certainty number. Then after that which comes, you may be thinking it's maybe the 4.3 or 4.5, 4.6 or 4.9. So these points which are not certain, that is called the uncertainty part. So the certainty number and the uncertainty number together is called as the significant figure. Okay. So the uncertainty is indicated by writing the certain digits and the last uncertain digit. Okay. So like for example, here I have given, for example, 11.2 ml is there. In this we are sure that it is 11, so it's definitely it is there. So 11 is the certain and 2 is uncertain. Okay, it can be 0.2, 0.3, something like that. So and the uncertainty would be plus minus 1 in the last digit. Okay, so unless and otherwise stated, an uncertainty of plus minus 1 in the last digit is always understood. So if I say that here some milk is there, okay, and I say that it is 11.2 ml. Okay, I am sorry, I measured it, it is 11.2 ml, but I am not sure about it. That means what a person will understand, that it can be either 11.3 or it can be either 11.1 or it can be 11.2. In between these two the value should lie. Okay, the uncertainty should be always plus minus 1 of the last digit. So last digit is 2 here, plus minus 1 of that 2. Okay, fine. So this is something about understanding what is the importance. Now here are the rules to calculate the number of significant figures. This is very, very important. Questions can be asked from here. Now if you see, first of all, the rule number 1 is all the non-zero digits are significant. So you can see here we have 3 digits, 2, 8, 5, all are non-zero. So we can say there are 3 significant figures. In this 2, 5, there is no 0. So we can say 2 significant figures are there. Now second rule, zeros preceding to the first non-zero digit are not significant. Such 0 indicates the position of the decimal point. So now you can see 0 present before the first digit. Okay, 0 present, the first 2 digits are not included in the significant figures, means this 0 will not be calculated, so you have only one significant figure. Here these 2 zeros will not be calculated, so you will have only 2 significant zeros. So here you should remember zeros preceding to the first non-zero digit. Okay, before the first non-zero digit, whatever zeros are there, these all are uncertain numbers, or sorry, these are non-significant numbers. Okay, next, zeros between 2 non-zero digits are significant. So these 2 non-zero digits are there, in between them if any 0 comes, that you need to include. Okay, that will be counted as significant figures. So here I can say the significant figure is 4. Okay, because I have to count these 2 zeros as well. Okay, next rule number 4 says zeros at the end or right of a number are significant provided they are on the right side of the decimal point. Okay, so one second, yes, so here it is saying that if there is any number, okay, where the 0 lies after the decimal point. Okay, like there is, see, suppose I write like this. Okay, now here you see these 2 zeros are there before the non-zero digit, right, before the non-zero digit, so we will not count that according to rule number 2. So here I will say there is only one significant figure. But what the rule number 4 is saying, that if there is any 0 after a non-digit number, okay, but these zeros are also after the decimal, then you need to count all the 3, all the zeros will be counted. So here I will have 3 significant figures. Once again I am repeating, there is a decimal there is a number and after that zeros are there, those zeros will be counted as a significant number. There is decimal, there are zeros and then there is a number. These zeros before the number will not be counted. Okay. Now one more thing here is, if you just write number and zeros, okay, in that there is no decimal point, in that case also these zeros will not be counted. Okay, that is the next thing here. Terminal zeros are not significant if there is no decimal point. Okay, so you can see in 100 there is only one significant figure, these two will not be counted. But if you count 10.0, if you write, okay, so definitely 10 will be counted, and this 0 is after the decimal, so that will also be counted. We will have 3 decimal numbers. Okay, so let me summarize it. The first rule is very similar. First rule and the third rule are very easy. Now second and fourth rule are little confusing. Let us understand it again. What does the second rule says, that if you have a decimal and after that you have any 0 and then if you have a number x, then these zeros will not be counted. Clear? The fourth rule says that you have a decimal, you have x and then you have zeros here. In that case, these zeros will be counted in the significant figure. And fourth rule, another point also says that since only if you have x 0 0, there is no decimal point, in that case also this one will not be counted. Okay, now we will do some questions, it will be more clear. Fine. So let us see the first one. You need to tell the number of significant digits in all these examples. Okay, now 3, 4, 5, 6, there is no non-zero number according, so I will also be telling you the rule that we are using. So according to rule number 1, there is no non-zero digits, then it will be all the digits are significant. So how many significant figures will be there here? 4, right? 1 second. Yeah, we'll get 4 significant figures. Next, coming to 0.666. So you can see we have discussed that after decimal, okay, numbers will be counted. Here all are again non-zero digits, so it will be 3. Okay. Now a question may arise that why this 0 is not counted. So you remember, zeros after that before the decimals are not counted, right? So that is why this is having only 3 significant figures. Next, coming to 5, this has only one significant number, sorry, this is only having only one significant figure. Now if you see here 10,000, the rule number 4 that we have used, what it says that if there is no decimal point, then the terminal zeros are not counted, means these zeros will not be counted, so we will again have only one significant figure. Next, if you see here, this is what these zeros are in between the numbers, and according to rule number 3, zeros between two non-zero numbers will be counted. So that is why we have 1, 2, 3, 4, 5, 6 significant numbers here. Now coming to this one. Now if you see here, okay, so zeros after the decimal point, okay, zeros to the right of the decimal point are being counted, right? We have just seen in the rule number 4 that if there is a decimal point and after that if zeros are added, that will be counted. So here also we have 4 significant figures. Now if you see here, this is also very easy, 4, because you have like 1, these are 2 non-zero numbers, so these zeros will be counted because according to rule number 3, zeros between two non-zero digits are counted. Okay. Next, if you have 0.005, here if you see we have to apply rule number 2. According to rule number 2, what does it say? The zeros before the decimal and preceding to the first non-digit number are not significant. You can see here, zeros preceding to the first non-zero digit are not significant. Okay, so that is why here this will not be counted. So we have only one significant figure. Here by using rule number 4, the same rule we used here, this one will not be counted, only 2 significant figures. Next, if you see here, we have 9021. Now see, this 0 is the last 0, terminal 0, and there is no decimal point here. So that is why this one will also be not counted, and we are having 4 significant figures. Next, if you count here, this is 1, 2, 3, 4, 5. So we have 5 significant figures. Okay, and what is the, I can say, rule here, that these zeros are between two non-zero digits. So that is why they will be counted. Now if you see here, these zeros will not be counted because these are the zeros before the decimal, and these are the zeros after the decimal, and there is a decimal point as well, so that will be counted. So we will have 3 significant figures. Now here you can see these are there, and these zeros will be counted because it is after decimal, so we will have 1 2 3 4 5 and 6. Okay. Next, if you see here also we have 1 2 3 4 5 and 6, and here we have 1 2 3. There is no decimal point, so this one will not be counted. So we are having 3 decimal places, or sorry, 3 significant figures. Okay. Now coming to precision and accuracy. See, what is precision and accuracy? Very shortly I'll explain you. So suppose an object is there, okay, and the actual value of its measurement, let it be for example length, okay, the actual value is 5 meter. Okay. Now student A, so let us understand from this example, then I'll come to the definition. Now suppose the actual measurement of something is 2 grams. Okay, there was a, you can say a ball. Okay, I'll discuss with this example first. So there was a ball, okay, and its mass is, accurate measurement is 2 grams. Now a student A has come and he measured it twice, okay, and in his measurement he got one time the value as 1.95 and other time the value as 1.93. Okay. Now what happens, these two values, okay, these two values are not very close to the 2.2 gram, because you can see some other students have measured 1.99 as well, right? So that is why. So there are two things. Now you have two measurements for this. One is 1.95 and 1.93. Now precision means that how close are the two measurements to each other regarding a particular measurement. Like for example, see, precision refers to the closeness of various measurements for the same quantity. You are measuring the mass of this particular ball, okay, and you got two measurements, 1.95 and 1.93. So if these two measurements are close, then we call that these measurements are precise. Okay, that is first thing. Now if these two measurements are also equal or very near to the actual measurement, that is your 2 grams, okay, they are very close to the actual measurement, then we will call it as accurate measurement. Okay. So now here what I can see, student number 1, okay, has got two measurements, 1.95 and 1.93. These two measurements are close to each other, right? So I can say the student's A value or the student's A measurements are precise. Okay. So let us make a table here. Yeah. So student A values 1.95 and 1.93. So I can say for student A, the values are precise. Okay. But if you take the average of these two, we are getting 1.94, which is not equal to 2 grams. Okay, which is not equal to 2 grams. So I can say, but not accurate. Okay, it is not accurate. Now let us see the student B's measurement. You can see here it is 1.94 and 2.05, and if you take the average, we are getting 1.995, which is also not 2 grams, right, which is not accurate. So definitely it is not accurate. Okay. But if you see the values here also, 1.94 and 2.05, these two values are also far away from each other. Means if you see, if I just draw a number line, okay, so we have like 1.9 here, and we have suppose 2. So I have 1.91, 92, 93, 94 somewhere. Okay, so let me make it like this. If I give you a number line, then it will be more clear. Okay, so let us understand from this side. So suppose I have 1.9 here, 1.91, 92, 93, 94, 1.95. Okay, then I have 1, 2, 6, 7, 8, 9, then I have 2, then I have 1, 2, 3, 4, 2.01, 02, 03, 04, 05. Okay. So student A measurement, if you see, student A measurement was 1.95 and 1.93. So 1.93 and 1.95, these two were the measurement, and they are very close to each other. Now if you see students B measurement, it is 1.94, okay, and 2.05, this one. So you see these two values are not close to each other, right? So that is why this is not accurate definitely, but it is also not precise. Okay. Now talking about student C, here the measurements were 1.99 and 2.01. Okay. Now if you see the value, if you take average, it is coming 2. So definitely we can say that it is accurate, right? And if I talk about the precision, it is 1.99 here and it is 2.01 here. These two values are also close to each other, so it is also precise. Okay, so that is how we can say a difference between the precision, precise measurement and accurate measurement. Precise means the values that you have measured should be close to each other, and if these two values are also equal to the actual value, then we can call it as accurate. Okay, fine. So now coming to significant figures, how to calculate when you add two numbers or when you subtract two numbers. Okay, so here the rule is the result cannot have more digits to the right of the decimal point than either of the original numbers. So we will come to rules later. First let us understand the example. So now you see, suppose I am adding these three numbers, okay, 12.11, 18.0 and 1.012. Okay, so here to the right of the decimal point, how many numbers are there? 2. Here it is 1, and here to the right of the decimal point I have 3 numbers. So that means the solution, the answer to this addition should also have only one number after decimal. Okay, it cannot have more digits to the right of the decimal point than either of the original numbers. Okay, so that means you need to select the lowest number after decimal, and in the answer, final answer also, it should have only one number after decimal. Okay, so now if I see, that means 31 point, it can have only one number, so this 122 is rounded off to 1. Okay, so I can write only 31.1. Now how this rounding off takes place, we will discuss. Okay, next we'll discuss in some time. Now let us see the next one. Suppose you are adding 1.457 and 83.2. 1.457 and 83.2. So after decimal, here we have 3 digits and here we have 2 digits. Sorry, here we have 1 digit after decimal, right? Yeah. So okay, so that means what? In the final answer also, okay, in the final answer also, after decimal there should be only 1 digit. Okay, now in case of this one, what happens? In this, I'll tell you why it is rounded off to 7, but I need only 1 digit, so I can say this 65, okay, 65 is rounded off to 7, okay, 84.7. We will discuss this rounding off rules after some time. So, but you should remember that it should have only 1 digit, okay. Next, why not 6 or why not 6? I'll be discussing that. Now, if you see this, if you add these two numbers, here after decimal we have 4 numbers and here after decimal we have 6 numbers. So, the final answer should also have only 4 numbers after decimal. So, if you see, we have 1, 2, 3, okay. 4th number is this one and this is 7. So, this number is rounded off to 4, okay. So, now what is the rule for rounding off? I have a separate slide for that, but we will discuss now only. Now see, suppose here 31.122 is there. I need to write only one number after this decimal, okay. So this number should be there, that this place should be there. So you need to check the next number, okay. You need to check the next number. If this number is above 5, okay, if this number is above 5, this place number is above 5, then this number will increase by 1, okay. So if it is above 5, then increase plus by 1, okay. Now if this number, okay, this number is below 5, then the same number remains, okay. And if it is 5, okay, not above 5, below 5, if it is 5, in that case what happens? In that case you need to check that, okay, first let us discuss that if it is 5, I will be discussing this case after some time. So now let us see this example, okay. So what is the rule? So the rule is, if you are having this number 31.122, right, 31.122. Now you see, I need only one decimal place only is available here. I need to have only one number. Now I see this number, right, 2 is less than 5, so that means this number will remain as it is. So it is 31.1. that is what is the answer. 31.1. Okay, now if you see next one here, 0.032378, and I can have only 4 numbers, 1, 2, 3. Okay, this 4 number you should check. What is the next number? This is 7 and this is greater than 5, right? If this number is greater than 5, then what will happen? This number will increase by 1, so I'll get 0.324. Okay, if this, so this number is the 4th digit. Okay, this number you have to check. The next number, if it is below 5, then it will remain as it is. If it is above 5, then it will increase by 1. Now what happens if it is 5? That we will discuss in the next slide. Okay, now let us first talk about multiplication and division, what rule you need to follow. Now see, here also in multiplication and division, you need to calculate in the, suppose you are adding a plus b, sorry, a into b. Okay, yeah, so you need to see how many significant numbers are here and how many significant numbers are here. The answer should have, like suppose here the significant numbers is 2 and here the significant numbers are 3, then the answer should have the least number of significant figures. Okay, so the result cannot have more digits to the number of significant figures than either of the original numbers. Means in original numbers, which is the least significant number, in the answer also that many significant numbers should be there. Okay, now let us see for the first one. If you see in this first example, 4.36, what is the number of significant figures? 3, right? We have 3 significant numbers here. And if you see, according to the rule that we have seen, these zeros before before the first non-zero number are counted as non-significant. So that means this will not be counted, and I have 2 significant figures here, right? So the answer, final answer should also have only 2 significant figures. Okay, so now if you see this answer, okay, is having so many numbers, it should have only 2 significant figures. So that means if I see 0.00056668, so I can write 0.0005 and one more number I need to write here, right? So that there will be 2 significant figures. Now this number is greater than 5, right? If it is greater than 5, what will happen? This number will increase by 1, so it will become 57. Okay, the final answer is 57. And you see here, what is the total number of significant numbers? We have 2 significant numbers, and here also we have the least one is 2 significant figures, so the final answer should also have 2 significant figures. Now if you see here, so if you see in this 12.300 plus 0.0230, now in the first you can see the total number of significant numbers is 5. Here the total significant figures is 5, right? Because we need to count the zeros after the decimal are counted, right? And if you see here, this 0 is not counted, but these 3 numbers will be counted. So here the significant numbers are 3. So in the final answer also we need 3 significant figures. Okay, the final answer we need 3 significant figures. So now if you see here, if I divide these two, we are getting the answer like this. Okay, so that is 5, 3, 4 and 7, 8, 2, 6, 1. But how many significant numbers I need? I need only 3 significant numbers. So I will write 5, 3. Okay, now if you see the next number here, 7. Okay, so this number I need to check. So this number is 7 and it is greater than 5. So if it is greater than 5, this number will increase by 1. So I will get 535. Okay, fine. Now let us see the round offing rules. Okay, I will discuss. So if the rightmost digit to be removed is more than 5, then the preceding number is increased by 1. Now for example, if you see 1.386 and I want to drop this last number and it is more than 5, so that means this one will increase by 1 and I'll get 1.39. Okay, now if the rightmost digit to be removed is less than 5, then the preceding number is not changed. Okay, so like for example, we have like 4.334. okay, I want to write only 3 significant figures. I want to drop this number and this number is less than 5, that means this preceding number will not change and it will be equal to 4.33. okay, now this rule is important regarding the 5. If the rightmost digit is to be removed is 5, means the digit to be removed is 5. In that case, the preceding number is not changed if it is an even number. So now for example, if you see here, 6.25 is there, I want to drop this 5. Now since the preceding number is an even number, there will be no change and it will be 6.2 only. But it is increased by 1 if it is an odd number. So if you see here, I am dropping 5, this is an odd number, so it will be increased by 1 and I will get 6.4. Okay. So now let us see this rule once again. Okay. This fifth one, what is saying? Suppose see, I have 6.665. Okay. And somebody told me, or the question is to write this number, okay, in 3 significant figures. Okay, 3 significant figures should be there. That means 6.6, then this number I need to check, but the last number is 5. It is neither greater than 5 nor less than 5. If it is less than 5, it would have remained 6. If it is greater than 5, I can increase by 7, but it is exactly 5. In that case, you need to check this preceding number. Okay, if this preceding number is an even number, okay, if it is an even number, then what will happen? If the preceding number is an even number, then there will be no change. Okay, so it will remain as 6.66. But if I write like this, okay, and you need to write it in 3 significant figures. Now if this so this is the last number is 5, so I need to check this preceding number, and this preceding number is an odd number. In that case, it will increase by 1, so I will get 6.68. I hope this is clear now. So now I'll explain this one, why it became, so now we can be clear. See, 84.657, clear? And here we have seen that there are total 3 numbers after decimal, and here it is only 1 number after decimal. So I have to keep only 1 number after decimal. So 84.657 is there, but 1 second, yeah. So we need to keep only 1 number after decimal. So we will check the next number. This number, if it would have been greater than 5, we can increase this number. If it is less than 5, we would have kept it like this. But it is 6, it is exactly 5, right? This number is exactly 5. In that case, what you need to check? You need to check whether it is an even number or an odd number. Okay. So as the rule says, you can, 1 second. What the rule says, if it is an even number, then it will remain as it is. If it is an odd number, it will increase by 5. Okay. So sorry. Yeah. So now if you see this number, right, this is an even number, so it should remain as it is. So this will become 84.6. Okay, not 84.7. So this is wrong here given. Okay, so it will be 84.6. Clear? So let us check the rules here once again. If the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. Okay, the preceding number was 6, which is an even number, so we need not change it. Fine. Now let us go to dimensional analysis. So here you should know that there are different units for a particular fundamental quantity. Like for length you have meter, centimeter, then kilometer. For weight you have gram, milligram, centigram, kilogram. So many units are there for a particular quantity. For time you have hours, seconds, minutes. For temperature you have Fahrenheit, Celsius, Kelvin, right? So you should know how to convert from one unit to another unit. So you can take a screenshot of this. Okay, this will be very useful, especially this volume part is very important, mass is important, time most of you will be knowing. Okay, so these units conversions you can take a screenshot and then you can use it while doing the calculation. Okay, so that is what is called as dimensional analysis. Now we will go to practice some questions. Okay, so here the first question is, the substance whose compositions are not uniform and different components are mixed are called as. So we have discussed that is called as heterogeneous substances. Okay, non-uniform distribution should be there. Next, which of the following is not a pure substance? So if you see copper, gold and water, but sugar solution has what? Sugar and water, and that is not in a fixed ratio, so that is why it is not a pure substance. Option number C. Next, point out an example of a compound. So in compound what happens, two elements of different atoms should combine in the same ratio. So ammonia you can see NH3, nitrogen and hydrogen has combined in a fixed ratio, so that is an example of compound. Option number C. Which among the 3 states of matter has a definite shape and size? This is very easy. So we know solids have a definite shape and size. Next, which of the following may not be a physical property? So we discussed physical properties are those properties, if you measure those properties, then their chemical composition will not change. Okay, so may not be a physical property, composition. Okay, so composition will change if you are measuring the chemical properties. Next, candela is the SI unit of, so we discuss it is of luminous intensity. Okay. Next, human body temperature in Fahrenheit, it is 98.6 degree. Next, convert 40 degrees Celsius to Fahrenheit. Okay, so this can be a good question. So what is the relation? We have degree Fahrenheit is equal to 9/5 into degree centigrade plus 32, right? So if I have this one 40 degrees Celsius, so 9/5 into 40 plus 32, right? So I'll get 72 plus 32, that is 104 degree Fahrenheit. Okay, you can see option is 104 Kelvin, that is not correct answer, that is degree Fahrenheit, option number C here. Next, dash is refers to as the closeness of different measurements of the same quantity, that is precision. I told you if you are measuring two values, how close are the two values measured with among each other, that is called as precision. Okay, next, multiply 1.2 and 3.91, obtain the result, okay, as the rules of significant figures. So you need to follow the rules of significant figures. So in multiplication and division, what is the rule? That you need to see both the numbers are having how many significant figures, and the answer should have the least number of significant figures. So first let us do plain multiplication and then we'll talk about significant figures. Okay, so I am writing this one. 391 and 12. Okay, I am just multiplying it. First 3.91 and 1.2 is there. Let us first multiply. 2 1s are 2, 2 9s are 18, 2 3s are 6, plus 1 7, then 1 1s are 1, 1 9s are 9, 1 3s are 3. If I add this 2 9, 9 plus 7 16, then I'll get 4692 and 3 decimals. So where to put the decimal? This is not there. So I'll put the decimal after 3 places, 4.692. Okay. Now in the first number, okay, how many significant figures are there? 3. In the second we have 2. So in the final answer also we need to have only 2 significant figures. So we need to have only 2 significant figures here. Now if you see, so this is the last significant figure. So this depends on this one. Now since it is greater than 5, if this number is greater than 5, this number will increase by 1. So we will get 4.7, that is option number D. Okay. Next, how many significant figures does this particular number have? So we have this rule 0.057. So this 0 is after the decimal. Okay, so this will not be counted. So we will have only 2 significant figures, option number A here. Next, the exact value is 150 meter. A student recorded as 149.1 and 150.8 in the second turn. Comment in his or her recordings. So we have 150, okay, sorry, okay, 150, and we have like 149.1 and 150.8. okay. So now if I take the average of these two, okay, 149.1 and 150.8, so I'll be getting 299.9 divided by 2, right? So that will be 2 1s are 2, 2 4 9, 149.48. okay, so I think that is correct. 2 9, then no, 1 second, just a second, let me divide it properly. So I have 2 1s are 2, 4s are 8, then I have 19, so 2 9s are 18, again 1, so 149.9 I will be getting. Okay, so I can say that the average value is very close to the actual value, which is 150 meter, right? So it is definitely accurate. Okay, it is accurate. But are these values very close to each other? I don't think so. They are not close to each other. So if they are not close, means they are not precise. So they are neither precise nor accurate. No, they are accurate, but they are not precise. Both precise and accurate. No, they are not precise, they are accurate. So I can say that the value is accurate but not precise. Okay. Next, this is a homework question. So a piece of iron is 5 inches long. How much it would be in centimeters? Okay, so dimensional analysis. You need to check the table, multiply the unit factor and then convert and find the answer in the units of centimeter. Okay. So yes students, this was the first class of PU1 of some basic concepts of chemistry. So here you should revise about scientific notation and significant figures and fundamental quantities. Okay, that's all in this video, and I hope this series will be helpful for you. So please remember your target 60 out of 60, and all the very best for your KCET preparation. See you soon in the next class, and do not forget to subscribe the channel.